All right, so gentlemen, as we're looking at this, ultimately there's two things I want you guys to be able to do today. And that is to essentially be able to handle explicit and recursive formulas and understand kind of what that means. That's really the big two concepts we're focusing a lot of time on today. There's a big difference between the two of these. We'll definitely see those advantages later. So what I'd like to do first is we're going to kind of walk our way up to these recursive and explicit formulas and get used to talk about things in terms of the nth term. What's the fifth term? What's the sixth term? What's the seventh term? And how we represent that numerically and algebraically. So we're going to kind of work our way up to that. So if we get into this first, I want you guys to tell me, what is a pattern? Recurring theme. Well, it's definitely a pattern is something that recurs. Okay, it is recurring. And I guess if we're thinking about non-mathematical sense, you could think of it as a recurring theme. But what does it mean to recur? To repeat, okay, or to happen over and over again. So as we look at a pattern, and we look at problem solving, pattern is one of those things that's super, super important to understand. It's one of those problem-solving skills that goes beyond the math classroom. Yes, we have mathematical patterns, but the way that we problem solve is we find patterns that happen all the time. For example, that I can think of right off my head is this winter, I kept having issues with my furnace shutting off in the middle of the night. It was great, you know? Yeah, it was awesome. We're down to like -15, but it's okay not to have any heat in the house, right? Oh, yeah. Great. Let's get along fine.
Well, you just come together.
Well, you see, this all actually started back, the problem, and then I figured out the solution to this, started way back in early spring of last year. And I noticed that we got down to like 50 or 40 degrees one spring night, and all of a sudden I wake up and the house is freezing, and I'm like, hey, what's going on? My first tries to kick on, and it won't kick over. So I finally called a guy out to fix it. And what happened is we have this pipe that's the intake, air intake for the furnace. And we had this plastic grid that was on this pipe, and the birds had managed to crack open the grid and build a nest in the pipe.
I feel like you told us this.
And so basically what was happening, the furnace was getting snuffed out. It didn't have any air to breathe in. So to fix the problem, so we don't have it happen again, ladies, the guy that came over to fix it took a piece of metal, basically grid, and slapped down in front of it, which worked out great. Never had a problem again. No bird's gonna be chewing through any metal anytime soon. Well, that worked out great until we hit to sub-zero temperatures. So then, as it's breathing in air, the exhaust is right next to it. So that warm, moist air that's coming out of the exhaust is coming up and instantly freezing over the metal grate. And so now I have this ice completely over the intake valve and stuffing up my furnace. And this happens frequently. So I'm talking about a pattern of recurring themes. Okay, it's a pattern. So I kept seeing this thing over and over and over again. So I started to first to stuff myself out, looking at a pattern. Where have I seen this before? When does this happen? Under what circumstances is this happening? That's all part of a pattern. And so that's basically how I learned to problem solve that particular problem. I finally said screw it and took off the metal piece and went back to plastic. Deal with the birds later.
Yeah, sure.
But now my question for you guys is, what's the difference between a sequence and a pattern? Are all sequences patterns?
No.
Okay, so then what makes a sequence different from a pattern?
It is certain. You can't be certain because if it's certain, that's a pattern.
Not necessarily, Christian.
Recurring order.
Well, that would make it a pattern. If it's repeating, it's a pattern. So what's the sequence then? Okay, let's throw some examples. Is 7, 8, 9, and 13, is that a sequence?
Yeah.
Yeah. Is it a pattern?
No.
No. Is 4, -8, 12, 2, 16, is that a sequence?
Yeah.
Not really. It's not a pattern. Okay. What's the difference here? How is this number These numbers right here. Think about the key difference between this list and this list.
One's a set of real. Is it negative?
No. They're not in order. Guys, a sequence is an ordered list. And some of those ordered lists have a recurring theme within them, and that's what makes it a pattern. Otherwise, it's just called a sequence of numbers. So, and I know, remember, we talked about the fact that in math, every single thing matters, every word matters, every symbol matters, right? And remember, we did midpoint, a lot of you guys wrote down this 2, 6, instead of parentheses 2, 6. Okay, if you write down 2, 6, all that is, mathematically, is a sequence. The parentheses are what make it an ordered pair. Okay, so there's that huge difference that's in there, guys. And to you, it might not seem like it's that big of a deal, but those two symbols make a big difference in how to interpret that information. All right, so now understanding what a sequence is and what a pattern is, I want you guys to look at the next two examples. What is happening? I want you to describe to me what's happening in each of those patterns. Amber? Adding 7 to every term. Okay, Blaine?
And then the second one, you're dividing by 3.
Dividing by 3. Is that hard?
Challenge.
Alright, so Christina, if I'm looking at that first pattern and I'm looking at 48, how do I find the next term? Add 7. Great. Alright, not that hard. Okay. So Kylie, what would I have to do in that last one to find the next term? Divide by 3. Simple stuff. Okay. Now the problem is, so Keenan, think on you for a minute here. What's the 20th term of the first sequence? Well, so we see a problem here, right? Finding the next term or the next couple of terms, not that big of a deal. By having to jump to that 20th term, that becomes a little bit more problematic, right? No one wants to sit there and list out, especially if we're having to find like the 150th term. No one wants to sit there and list all 150 terms. It's a pain in the rear. Okay? We do have a way around that, and that's basically what